Hi. Give me 1 second. I'm about to get this presenter in. It's a printer? Crap. All right. Whew, just had lunch. Feeling really good. Feeling happy. So, my name is Brandon. I do engineering stuff for a company called CyberArk. This is not plugged in, so I'm going to go ahead and do that. While I'm doing that, I guess my bio's in the thing, so I'm not going to talk a lot about me, because you guys didn't come here to talk about me. You came here to talk about security fails and DevOps and unicorns and rainbows and ponies and all the stuff that kind of comes with the cloud adoption, DevOps adoption, and stuff like that. But while we're all coming in and getting settled, I think it's very important to start this with just a statement that this session, this room here, it's a safe space for people who've committed IT security sins. If you, sitting right there in your chair and being a big stupid liar, have not done any of these things, if you are so wonderful and lily-white that you've never written down a password or copied an SSH key from a prod system to your own box because you wanted to authenticate all willy-nilly forever and ever like you want to, if you have never late night went by Taco Bell, grabbed some delicious Crunchwrap Supremes, then crushed it in the car in the parking lot because you didn't want your significant other to know, get out. Like, leave. Don't stay here, because the people around you will shun you. You will not be one of us. Just like I thought nobody left. Or they're just sitting there right now being really scared about what we're all going to do to them if we find out. So, how many of you go to Black Hat, or like the big security vendory conventions? Anybody in here? Okay, cool. So if you went to Black Hat, probably 2016, something like that, you would have noticed that no matter where you went on the vendor floor, you saw cloud everywhere. The year after that, you went up in there, you saw AI, behavioral analytics, AI. Then a year after, before, I don't really remember, you saw DevOps. Now, why is he saying this? Well, C-levels, CISOs, CIOs, folks like that, love to go there and they see this stuff and they come back and they're like, hey, security team, we're going to do cloud. Can you help us do cloud? Help us secure that. Or DevOps, we're going to make a ton of money doing that. Security team, figure out how to secure that whole DevOps thing. And you look around, you're like, well, shit, what do I do now? The company I work for, CyberArk, we tend to come in and do security consultancy, things like that. We also sell a product. I'm not going to talk about that. But we hear this conversation all the time. Security comes to us saying, guys, what do we do about this? Well, first of all, you've got to recognize that the environment has changed. And I submit to you that change has made it easier for those of you who do offensive security to pwn the hell out of environments. And I'll talk more about that too, as well as ways that we can kind of make the pwnage a little bit harder. But what I've seen personally in this whole cloud, on-prem to cloud migration is a couple different things. The first is, right, we're having an increase in scale. Now that is including the threat surface. Back in the day, you had an on-prem data center. You had like something like 300 servers in there. Right? You've heard the whole, servers are pets and containers are what do they say, cattle. That's really slaughtery for me. So I prefer like tissue, like Kleenex. Right? How nasty is that to think about containers? Like you blow your nose, you throw the Kleenex away. Same is true with containers. Now, the increase in scale means that our development teams, even some of our security teams, are kind of slowing down the security part of it because scale is hard to secure. So I'll talk about some best practices there. The other thing we're seeing is, again, no more pets, right? So as we provision new containers, we're forgetting the part about how container hosts are just kind of like hypervisors, and if we don't do anything with the password there, if it's the same across 3,700 container hosts, bad guys make it, have a very easy go of moving laterally. The other thing that we're seeing quite a bit in terms of cloud migrations is nobody's really standardizing on one platform, like it's not a thing. And you see it case in point with the cloud thing. So about 4 years ago, if you were to ask a company, hey, who do you use for like infrastructure as a service? They'd probably say something like, well, we use Amazon Web Services, and everybody else is dumb if they use Azure, or, well, Google was just kind of a glint, but it was still coming. Now, completely different. Like, oh yeah, we use AWS, and this other team, they're using something else. This other team is using some weird cloud thing that we don't even know about, because our developers in those teams are being told, hey guys, use whatever makes sense, right? Search Google, find something, find a tool, do it. Your job is to make money for the business. So we're seeing more non-homogeneous environments, which makes it hard on security because it's really hard for us to say, well, I'm going to standardize this policy and this rule set. Well, what about Azure over here, security guy? What do you do there? I don't know Azure. So we're getting that quite a bit. The biggest thing, and the thing that I'll probably talk about quite a bit, is with this increase in scale, with jumping on this beautiful DevOps train, choo-choo, unicorns, barfing, all kinds of rainbows, we do have more non-humans that are automating processes that humans would have taken. It's the whole point of DevOps in general, right? For developers and operations teams to come together, build automated processes so that they can go home at 3 o'clock and drink beer while you're still making security policies. That's the whole goal of what DevOps actually is. So we need more machines to actually do this work. I'll talk a little bit about the dichotomy between kind of machines versus human access role and stuff like that. The final thing that we've seen that really hurts me is the human actors that are managing these processes. For instance, we all seen Terminator, right? Skynet, pew, 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 Terminator, stuff like that. Somebody had to press a button and say, this is a good idea to start up Skynet. The same is true with our cloud automation and DevOps processes. A human administers it. A human puts together the policies that become the framework of the beautiful automation we've created. Those humans are typically given way too much rights and too much power, and security teams are told, guys, whatever, they're DevOps, they do what they need to do. So from an attacker standpoint, those are the guys I want to start targeting now, and gals too. But one very important thing that I'll tell you is, even though everything is shifting and migrating, everything's fine. We're not seeing compromises based on these economies of scale that I mentioned. It's not like every single breach in recent memory, the past 2 years or so, has involved some sort of secret existing in public source that's wide open. That doesn't happen. Security, whatever. We don't care. Now, before I talk about how things are different, by the way, sarcasm, in case you didn't, I'm sure you know. I'm sure you knew. You guys are cool. Before we jump into that, I'll submit to you that even though things are changing, your typical threat path is pretty similar. Right? Regardless of whether we're dealing with an on-prem data center that has a crusty old 1979 IBM Z-Series mainframe versus cloud-focused workflows, we're still going to follow the same process, right? Compromise the hell out of somebody because humans are the easiest things to break. They're also nice to talk to. I enjoy doing it. Then elevate privilege, move laterally, move, find the thing, elevate privilege, compromise the environment, yay, profit. That's what we want to do. But what I'll say is changing is the number of hops. Now, how many millennials are in the room? Any millennials in here? Yeah. What's up, millennials? By the way, the Millennial Club meeting has moved from 9 p.m. to 10 p.m. tonight. Make sure you bring as much YOLO as you can. We're going to need extra for the hour. No, so when you talk about millennials, me being one, you're looking at the face of security today, but also the face of your attackers. And the one thing I'll tell you about us awesome millennials is that we are very efficient. Now, some of you may say, efficient, lazy. I like to think it's efficient. Thank you very much. Now, when you look at it from an attack flow, you look at the old way, right? Move laterally through a data center. That's dumb. It takes a lot of work. I may actually have to talk to people or do something instead of just hanging out, watching Netflix and doing whatever us millennials do with with whatever applications. I don't even know. But instead, what if I target, say, a company's cloud presence, company's cloud environment, particularly around the infrastructure as a service, the platform as a service? If I'm able to compromise a user, grab a privileged access key, secret key pair from their desktop, done. I've owned the entire environment. I have access to PII, all kinds of delicious stuff. If I didn't want to create an irreversible network takeover scenario and hit their home DC, I'm done. If all I wanted to do was pull back important information, get credit card numbers, whatever it may be, all I have to do is look for instance, their AWS instance. Now, the title of the presentation was Zero to Own in 1 hour. Where does the 1 hour pop in? CyberArk offers red team services. We do this. I imagine many of you offer these types of services too. If you're targeting privileged access into cloud environments, it's like back in the day when people used to save passwords in text files. You can hit an administrator's desktop and actually find the access key, secret key pair either on the desktop or, better yet, not to bag on Amazon too much, it's just the one that we see most often. The Amazon Web Services CLI saves the authenticated credential in a file, in a flat file that you can find User context, you don't have to elevate privilege. You're done. That's all it takes. We have seen this play out over and over again. The one that I'm talking about here, financial institution, actually pretty big, went through the same process. We were able to attach their S3 buckets to our instance, and we had all kinds of delicious customer data, customer records, social security numbers, all that good stuff in a couple of hops. It didn't take us 1 hour, though. That's a bit of a lie to get you to come in and sit down. It took us about 3 hours or so for this particular exercise to execute. I know, right? Now, what you're going to do is you're going to take this back, if you work for a company where you're involved in the security stuff, and you're going to say, guys, what are we doing about cloud security? And what they're going to tell you is, well, no. Microsoft, Amazon, Pivotal, Google, they control the security of the cloud. They say they're secure, and they are. We're fine, right? Well, not really. They do a very good job, these vendors, of controlling the security of the cloud. All the plumbing, right, the stuff that goes into making cloud compute a thing, they're responsible for securing that stuff. It doesn't change the fact that the stuff we put into the magical cloud thing, which is just somebody else's computer, is still our responsibility. We are still custodians of that data. So if you take anything, this fallacy, I imagine many of you don't think of it that way, but if you put it like that, like, guys, they're responsible for security of the cloud, we're responsible for security in the cloud. Somehow that just clicks for people. They get it. We have this conversation pretty often. I do personally as well. But if you have to do one thing, right? So if this isn't something that's part of the security process, if you can't look at it until next year, right, building an entire cloud security strategy, start with what you know. In many cases, when we establish identity or PAM or privileged access security programs, we start with humans. And it's easy to do, right? People you can talk to, people you can take to lunch, people you can steal things from. It makes sense to start there. Human access into management consoles is the single point that you can add tons of security value with very little effort. Multi-factor the hell out of your AWS, Azure, or GCP management consoles. These vendors think it's so important that they already include that functionality. And also, if your users are asking to leverage the AWS root account, tell them no if you can. They have identity inside of these things. Use it. Least privilege exists there. So that's the one thing you should focus on first, right? Admin access into the Cloud MC, because really, if I don't have to find an access key, secret key pair, all I really need to find is a user's AD password, because you're probably doing some kind of federation, then boop, I'm done. If there are roles, at least there's some least privilege there to stop. Now, there are other ways that you can perform security, things like session isolation and monitoring, actually rotating those credentials, stuff like that. But when you do look for this stuff, always challenge your security vendors, your jump host vendors, your PAM vendors, to provide a user experience that doesn't just completely suck ass. Don't make users log in through another interface, check out a password, and then go do something else. Have it stream through. Make it sexy. One of the things that we see a lot in terms of enablement for cloud engineers and DevOps engineers is they're spoiled because their job is to enable the business. Their job is to move fast. And I'll talk a little bit about we as security can learn from that in a moment, but look for ways that you can make their life easier while invoking security. And again, I'll talk more about that later. And the other thing is, if your company right now standardizes on AWS, for instance, don't anticipate that it is always going to be that way. If you are responsible for building this cloud security strategy, and you're studying up on AWS and you're feeling really good about it, I implore you, read more about Google Cloud Platform, read more about Azure. Last year, Amazon acquired Whole Foods. For our customers who had standardized on AWS, who were in the retail or grocery space, they were like, whoa, well, AWS is now kind of a competitor, isn't it? Well, crap. Okay, well, and C-Level says, in 3 months, we're shifting everything from Amazon to Azure. Security team, go. I trust you. I believe in you. These things happen. Amazon will continue to acquire stuff. Microsoft, Google may also come in these spaces, so plan for multi-clouds. But don't just stop at looking at the kind of the quick cloud administrative console. There are a number of tools that make up the pipelines that are kind of commonplace in cloud automation, but also when we start to sprinkle in the DevOps framework adoption. One of those that I love to point out quite often is good old Jenkins. Jenkins is just fun to say, by the way. Maybe it's Leroy Jenkins. Maybe that's where it comes from. Because I don't think of a butler, right? I just think of a guy running. That doesn't matter. So what I did was, I was like, okay, how do I really talk about Jenkins being insecure? And I thought back. By the way, do we have any folks from utilities, energy, anything like that in the room? Couple. So like 2 years ago, Georgia Tech did a POC where they created a piece of ransomware that was specifically targeted at a certain brand of what are called PLCs, programmable logic controllers. They control stuff with logic that you program. But this particular one targeted PLCs that weren't supposed to be internet-facing, but were. An industrial control system, a thing that should be in the most air-gapped of air-gapped networks, is somehow open to the public internet, typically using default admin credentials. This piece of ransomware was designed to hold a municipality's water supply for ransom. If you don't pay up, we will increase the amount of sanitizer to fresh water, potentially poisoning your entire populace. Superman 3 style. It was cool. It was totally awesome. It didn't actually happen. It was never deployed. It was just a POC. It was for funsies. But Jenkins is kind of the same way. So doing a quick Shodan search actually pulled back, 214.5 thousand Jenkins instances that were accessible over the public internet. And you're thinking, okay, well, they probably have SSL enabled. They're probably not using default credentials. And I can't tell you about the last one, but look at this. 33,000 of them have port 8080 open to the public internet. Good old port 8080. It's not quite 80. It's more secure because you put another 80 in front of it. It's totally fine. Why did this happen? Well, I'll tell you why. I'll give you this is an opinion all the way. It's because we were provisioning so quickly, the automated bot, the thing, did not add security into the mix because our developers didn't know better. It's not that they're trying to work against us. By the way, I'm a previous developer. I'm reformed, but this was me in a previous life. I got better, I think. But we didn't know. We just did it. So these are things you can look for. Jenkins is the new domain controller. It's the domain controller of DevOps, by the way. This is something you can run on your own as well. But have those conversations. Like, guys, are you exposing your management console for internal nodes to the public internet? If yes, why? Like, buy them pizza, take them out to lunch. Have that conversation. It's really all you need to do. Scare them a little bit. It's a thing. And by the way, many of your vendors will do this with you. Like, if you have a security vendor who works in the cloud or works with DevOps engineers, like, we love having those conversations. They don't scare us at all. But for people, look at your management consoles, your one-stop portals to get the whole world make life easier, also make life easier for your attackers too. It's what we do over and over again. But what about the non-humans? There's something about application processes that tends to send your traditional security engineer for a loop. It's a little bit different. Yeah, it involves code, but many of you in the room, I'm sure you write your own code all the time, so this is nothing. And yet somehow things like this happen. This is just a simple Jenkins build script that exists right here. It's just in a private code repository. A beautiful access key secret key pair right there in plain text. Just love to see those. Somehow, and this is okay, right? This is a dev environment, lower environment. We're just getting our job done. But somehow that bad boy ends up in a public source repo inside GitHub. Now, pretty much anybody, whether it be somebody just typing on their keyboard or someone using a tool like TruffleHog to find very high entropy items, is able to find that and then do whatever they want to do. Now, if you don't believe me that this is super easy to do, not right now, but later, whenever you feel like it, pop open your laptop, go to GitHub, search for AWS_secret_key, and sort by recent code commits. I nearly guarantee you that you'll find something, a hard-coded access key secret key pair, in like 10 minutes. Maybe 5 minutes if you click through real fast. Maybe 1 minute if you get lucky. This is happening all the time. Again, those automated processes are allowing it to go. And this isn't just for one particular type of system. In pipelines, DevOps or no DevOps, we have multiple things authenticating to other things too, typically, again, using hard-coded secrets. A lot of times, we'll see them be the same username. So the username is the password, or admin is the username, password is the password, or you go root Calvin like with Drac systems. It's like the same stuff here. It continues to happen. Now, for those of you who may not be super familiar with a pipeline, all it really is a process that moves one thing to another thing and has the telephone game in between. A pipeline can be to deploy code, it can be to provision new servers or virtual machines or containers, whatever. A pipeline is where you put something in it, it comes out at the end, typically changed, and something has been done. In a very simple pipeline, for instance, having Jenkins pull code from something like GitHub that then does work on provisioning a new Docker image, putting it into an artifact repository, and then leveraging something like Ansible, Chef, or Puppet to actually do the thing, you've got something like at least 6 different things that are authenticating in that process. Boop, 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 all day long. Jenkins will typically hold the credentials for every single one of them. So that cute little butler right there is actually a big frickin' jerk when it comes to security. He does things for us, though, right? We don't want to hinder automation. This is why when a lot of times you'll come to this and you'll say this again to the internal staff, they'll say, security, you don't understand. You guys are super slow. Where's your suit? Where's your tie, security? Well, because that's a perception thing. But again, simple pipeline. In many cases, a company will have way more stuff that is involved. In fact, sometimes, by the way, when you have this conversation with your DevOps engineers, they'll just throw tools at you. You'll be like, well, Jenkins, I know holds a lot of secrets. We're actually looking to secure that. They're gonna be like, well, what about Cloudfish and Cloud Burrito? What about Velocity Taco? And you're like, what? Velocity Taco? Like, because we're dealing with so many small things as part of a pipeline, tools are just popping up that do very similar things. Don't let that discourage you from having the conversation. I'll talk more about how you can kind of generalize things in a bit, but really a quick Google search, you can say, oh, well, dang, Cloud Taco works a lot like Bamboo. Oh yeah, it's kind of the same as Bamboo, but it's open source. It's like, okay, guys, we have it. Let's have that conversation. But as a previous developer, that was my strategy too. If I could throw enough tool names at the security team, eventually they would leave me alone. Don't give up. Don't. But again, it's a perception thing. A lot of times when we start to invoke security on something, people on the development side tend to think that we're trying to slow stuff down. Again, go find your tie security. We're designed to go fast. At Black Hat this year, I saw an interesting t-shirt. I liked it a lot. It said, security is always right, which is true. Kind of are. But if I could ask you to do one thing, when you're dealing with these cloud and DevOps processes, in the back of your mind, security's right. You're right. Remember that. You're awesome. Look in the mirror every day. People like you. You're smart. All that good stuff. Affirmation style. But try to understand. Take that shirt and modify it to security is always trying to understand what's going on. If you just have a conversation with your developers or your DevOps teams about what they're doing, your cloud architects, be like, hey, what are you doing? Oh, well, we're deploying this and this. It's like, okay, cool. How are you securing that? What do you mean? No. Just like how can we help? Because I'm going to come find you. I'm going to be there eventually. There's going to be a directive. So tell me now. If you tell me now, we can start to work things out. Guys, it sounds crazy, but it does work. It's really efficient. And you can throw out very simple things like, hey, developers, maybe don't put secrets in source code. Well, where are we going to put them? I don't know, like a vault or something, maybe. There are open source tools out there. I'll tell you about a few of them in a bit. But if you provide something that they can put the secret in, well, now you're providing it to them as a service. Now you're saying, hey, guys, don't worry. You put the secret here. It's going to be secure. Maybe we rotate it. But it doesn't matter to you. Your application can keep doing what it does. Oh, really? Like, I don't have to worry about you coming at me and having to manually change 7,500 passwords as part of my dev process? No. Just let us store it. Okay, cool. We'll do it. Also, for applications, we tend to overprivilege, right? So, and this is true of legacy applications too. If you come across a service account in your environment, it's something like Skynet_SVC, which I've seen a ton of times. There's a chance we've given that bad boy full carte blanche domain admin access, and the same is true in cloud environments too. Look at least privilege for applications, especially the visible ones as well. A lot of you, at least in our conversations, have said, Cyborg, do you really need super all-powerful privileges? No, probably don't. We can do it with least privilege too. Always challenge folks who are providing security as well as automation solutions on that. Next thing, never ignore the audit trail when it comes to applications. They're just as important as people, if not more. An application shouldn't be able to be a faceless entity that's able to nom down all sorts of secrets all day long. It should be auditing. I should be able to know what Skynet_SVC did. We should be forwarding that to our syslog, our SIM solutions, all that good stuff, especially for the visible ones as well. For instance, outside of cloud and DevOps, you should know when your vulnerability scanners are logging into systems. You should know of the pattern. That way, if you're not changing the passwords, and you should, you can be able to tell when a bad guy is using your vulnerability scanner service account to do naughty things. I'll tell you a story about that in a bit. Finally, don't do stuff manually. If you tell this, guys, we want to take away as much manual stuff as possible, like you rotating your passwords, or you copying SSH keys to target hosts and having to forget about them. Automate. Automate your security. This is true of you telling them, but also doing it yourselves. A lot of successful security programs are taking up the same types of automation schemes as our DevOps teams are doing as well. If you can automate the onboarding of new accounts into your identity platform, if you can automate the onboarding of new systems into whatever asset management solutions you're using, it means that you've got time to go home at 4 o'clock on Friday and crack a beer before 5 hits. It's simple. Automate as much as you can. You can learn from your DevOps teams too here just by having the conversation. The other thing that we see a lot is what are called islands of security. What does that mean? That sounds really marketing-y. Well, we like islands because islands are fun. But a lot of times when you have this security conversation, your teams will say, oh, well, actually, we use Puppet. We're using Puppet here to store our secrets. And you're like, okay, well, at least you're doing something. Or, you know what, actually we're using Docker Vault to store those secrets. Or we're using the vault of this solution that isn't a security solution, but they put in some sort of secret storage capacity because we asked for it as a user base. Don't tell them not to do that. It's important to do. However, if you've got a bunch of different tools, as security, you run into the risk of having to now go out and master every single one of these bad boys, which you probably don't want to do. So, don't tell them to not use it. But if you have a bunch of different tool sets out there and we're all doing kind of secret storage inside of these, as well as on the file system, as well as, and hopefully not, but probably public source code repos, look for a way to centralize that. Start with the most visible application or process, the team that you know best, the team that you have friends on. If you make a successful move from a completely fragmented system to a centralized management portal, something like that, the word will spread. People will start finding you and saying, can you manage our credentials for our applications? Can you do this? Really? I'll pay you. No, they probably won't do that. They probably won't say that, but you know, I can hope. So, some good practices. Again, a lot of theory stuff, but some things to take away, some things that you can immediately take to the team, have conversations with, are these. If you're using secrets, if secrets are communicating from one place to the next, if secrets are being stored somewhere, they need to be encrypted. Even a little bit. Many libraries are already there for your developers to be able to do it. All you have to do is ask them, hey, is that happening plain text over the wire? Yeah. Don't expose port 8080 to the internet. At least have it be, A443? 443, right? At least use a self-signed certificate. Guys, come on. Step 2. If you've got old secrets, rotate them. Even if it's manually once every 2 years, it's still better than having that secret be out there for 10 years. It's the same. I happen to have in a cloud storage solution, a free one, I have a private key from when I used to be a Unix application owner. I'm almost certain that I can use that private key if I were to get on the old corporation's network to authenticate to any number of critical tier 0 Unix servers, because they don't rotate those. I never had to. I had that bad boy for 4 years. I loved it. When I discovered SSH key authentication, I was the happiest Unix admin in the whole wide world, as many of yours might be too. So rotate your secrets, especially if they're dealing with very critical information, segmented environments, customer data, all that good stuff. Even a manual change once every 2 years is better than nothing, like I said. Also, when you do go to a secret management platform, your developers are going to say, well, that doesn't run inside of OpenShift. You mean I got to call outside of OpenShift to get into OpenShift? Well, no. If you find the right stuff, you don't have to. People want things to run natively, to run close to the application. There are benefits to it. If you have a secrets management platform running right next to your application, it means that you can take advantage of any redundancy and availability built into that platform as a service. By the way, when I say that, I'm talking things like Pivotal, OpenShift, Kubernetes, container orchestration platforms that we're building a lot of our DevOps processes on. Finally, as you move to this, look to least privileged applications. Always ask, does that need domain admin rights? Does that need full cloud AWS admin rights? Probably doesn't. maybe scale it back a little bit, or better yet, how? How would you, team, recommend that we scale it back if you want to have that more consultative discussion? Audit the hell out of everything. That's a given. I'm going to talk about that. And then finally, automate your processes too. Anything you can do to make life easier. Automate yourself out of a job means that you can advance or go home early, depending on what you like to do. I mean, I don't know. Depends on, I guess, what matters to you in life. Maybe, why not both, right? Why not both? But try and centralize as much as you can, too. Now, when you come into centralization, the biggest thing is going to be, well, I don't want to put all my eggs in one basket. Challenge the hell out of your baskets. I say that as a vendor. You need to take us through the ringer. That's what we're here for, right? Always ask the hard questions. Never be afraid to do so. Now, once you've done that and had those conversations, the nirvana state, that beautiful security state of DevOps that we want to get to, is simply this. We don't want to slow our developers down. We want to be seen as an enabler, not as a constraint. If a developer or DevOps practitioner has ever called you a constraint, you know you've screwed up royally. There exists a book called the Phoenix Project, written by Gene Kim. It talks about the concept of constraints in DevOps. All that is anything that's going to slow me down and make my life miserable. In 2016, there was a cloud trends survey about cloud migration and blah, blah, blah. It said, of the respondees, 90% said they were moving something to the cloud. 20% of that 90% of people who said yes, actually, I'm sorry, never mind. All those respondees said that 20% of workloads were effectively migrated. So 90% of people doing it, 20% of stuff was actually successful. And when asked what the biggest thing that was slowing them down was, what do you think they said? Yep, security. They suck. Hate them. But we are seen as a constraint. It doesn't have to be that way. Again, by automating processes, by making life easier, we can become that enablement. We can become the superheroes for our DevOps teams. And it's actually pretty cool to get recognition from your devs for doing something nifty. Also, when you're looking at putting security into the DevOps pipeline, it should kind of be a little separate, so you don't have to be a total master of OpenShift to invoke security. It needs to run outside of that platform too. Also for availability, for scale, and while you can allow developers to manage different security policies, at the end of the day, it's good, but you should be the end. You should be the piece that sets the initial policy and allows developers to work in around it. And I could talk about this for hours, so I'm not. Now, when it comes to talking about a pipeline, when developers say, how are you going to secure my pipeline? What happens? I use tool XYZ, A, B, C, D, E, F. I'm going to give you a hint, a little secret. Most pipelines are pretty similar to each other. Now, this is a grand generalization. But again, if it's something that you're a little bit new to, a typical pipeline is going to work a little bit like this. You've got a server, a process, a thing that does stuff, orchestrates things, is responsible for a task. Now, what it'll typically have is it'll have some kind of account it uses to authenticate to do its tasks. And again, this can be whatever vendor we're talking about. Now, once it does that task, maybe it's provisioning a new container host, new containers, new virtual machines, new, for robotic process automation tools, new robots that are going out there and performing stuff. Well, it typically provisions a thing that has some sort of secret associated to it. Right? So now we have a brand new secret for something that's typically hard-coded and exists forever, and it's probably the same on all these nodes too. Just like admin passwords used to be the same in a lot of environments. If your admin passwords are the same, like your local admin passwords are the same, I'm sorry. You can change that. It's easy to do. We can talk about that. But typically the same. And then a lot of times when we provision something, there's an application on there that now has a new hard-coded secret so it can authenticate to do other stuff. And then the process continues in this super big wheel thing that goes on. So what do? Find something to store these secrets in, whether it be free, paid, enterprise, whatever it is, OSS, so that A, your orchestration server can now make a call back to the secret storage platform. A lot of you are wondering about the secret zero problem. You're probably thinking that. I'll talk about that in a moment. Once it pulls the secret, which you can rotate from the thing, and provision something new, programmatically onboard that something new into your identity management platform or your server management platform or your system management platform or even the same solution up there. Now these secrets can be different, so bad guys can't move laterally across whether it be your on-prem environment, traditional, or a more cloud-born environment too. Again, this is the same nearly across the board. Finally, when you provision an application onto one of these nodes that you've created, have that thing call out to the secret store just like that thing did. boom, and it just goes around and around and around and around. Only these passwords are changing. They're not existing in a hard-coded state. They're not variabilized. They're not existing in public code. That's it. That's all there is. Start with a vulnerability scanner too, if you just want to see how it's done. That's all there is to it. Now, I talked a little bit about least privilege of applications. And I talked about how somehow it scares security teams a little bit. And I'll tell you why. So when we look at establishing identity for human processes, we see some fellow like Bill. Bill's a happy guy. With people, it's very clear to define or to get their identity. If you come up to me and say, "Who's this guy?" Well, it's Brandon. Well, because you were told it was me by the awesome introduction I had earlier. I'm Brandon. What's up? I got proof. You can also check my ID, which is real, I promise, to see who I am. You'll probably, when you steal my wallet, because I imagine that you found out I was Brandon so you could hit me on the back of the head, knock me out, and steal my stuff. So once you pull my wallet from me, after probably hurting me quite a bit, you'll likely find my business card too. You know what I do. You know what my role is. So I have who you are. I have what your role is as well. You may also have found my phone, or even an RSA dongle, something like that. So you would have proof that I can perform multi-factor authentication, and you would have found that I'm warm and friendly because I allowed you to talk to me so that you could hit me. Hopefully, I am still warm and not cold and dead, but you've established my identity somehow, and it's pretty easy to do. Whether you hit me or just talk to me, either way is fine. But applications are a different story, a completely different beast. And to a security team, they typically look like cold and unfeeling robots. Because once you do a scan because you didn't want to talk to your application team because those guys and gals are super weird, you would find that there's really no identity associated with these accounts. SVC11285 or some nonsense like that. And you're like, ugh, I'll worry about that later. Applications can't really multi-factor, can they? Right? An application authenticating to something, how's it going to prove it is who it is? Well, no, we authenticate applications based on what they know, not what they are. Well, there are ways to do it the other way, but that's neither here nor there. There are solutions out there that do that. It's hard to identify the role, the identity. It's hard to identify any sort of multi-factors of authentication. But I think we're looking at it the wrong way. Instead of looking at application server WA113, that's Wally. By establishing machine identity for our applications, whether that starts with simply creating functional accounts for them. This account I will give to Qualys. This account I will give to Jenkins. This account I will give to Chef. It's a little simplified, but by doing that, by having that conversation, by even mapping what you have going on out there, you can begin to establish identity for these. The roles come out too. By even talking to the team, saying, oh, hey, application owner Bob, I see there are 5 service accounts on your system that haven't changed in the longest time ever. What are they for? If Bob says, I don't know, bring them under management. If Cindy says, ooh, I know 1 and 2, well, Cindy, how can I help you with managing those? Right? They exist out there. I want to help you secure them and make your life easier. And Cindy's going to be like, yeah, cool, do it. Whatever. I don't care. I got other work to do. It's not bothering me. Again, there are ways to do this. We can chat more about that as well. But always look at ways of establishing some kind of identity for your non-human processes too. But even when you've done that, applications have a hard time multifactoring, as I mentioned. There are solutions out there that offer secret management that allow you to authenticate an application based on attributes of it. Things like a hash generated at runtime that's compared to a hashed value that was done during SDLC. The hashes don't match, the application can't pull a secret from a central store. Things like Kubernetes and OpenShift authenticators that authenticate an application based on the pod in OpenShift or Kubernetes that it's living on. Applications do not have to authenticate with hard-coded passwords. That is a thing of the past. Like I said, there are open source solutions that let you do this. I'll introduce you to one of them. But what's the goal? The goal of all of this, right, from managing human access into cloud and our DevOps tools or whatever it is that a human accesses, to managing applications doing stuff, the goal is to establish some sort of policy that can be spread across environments and across systems. Why do we do this? Well, number one, it makes our C-levels incredibly happy. We like happy C-levels because a lot of times they give us raises. C-levels in the room, you should give your people raises, by the way. Number two, yeah, cool. Number two, what is number two? C-levels, blah, blah, blah. Number two, it means that attackers that are super lazy and millennial like me aren't going to target the same things over and over again in the cloud segment that we always know are going to be compromisable, right? If you establish the same level of multi-factor you do for your cloud environment that you do for your end users on their workstations, you are good. If you're not doing that, think about it. Like, it's super quick to do. Right? So by having some sort of central enterprise policy, we can make our CISOs happy, we can make our lives easier, and we'll make our auditors happy too. Who doesn't love a happy auditor? Who doesn't? Never mind. I'm not going to ask the other question. So, we're coming close to the end. And there's one thing that I've not done. One of those is likely inform and or entertain you. I probably haven't done either of those. But the other thing, the more important thing, is that I have not given you free stuff. Now, I don't have a raffle. Like, this isn't like free stuff that you can like grab and take home. Sorry. I mean, you can grab it at some point, but you can't. It doesn't matter. A couple free things I want to talk to you about. The first is, we talked a little bit about the concept of finding accounts that are being used out there, in the cloud, not in the cloud, all that good stuff. A number of vendors provide solutions that are free that let you do this kind of stuff. At DevCon 2 years ago, one of those that was released was called Bloodhound. Anybody use Bloodhound? So sexy. Like, honestly, being in the room when Bloodhound was unveiled was a lot of sweaty people, number one, which was cool. There was a lot of sweaty excitement, which was my favorite part about it, I think. Ask me about that later if you want to. CyberArk provides a tool like this. It's actually was around before Bloodhound. It's called DNA, or Discovery in Audit. We're really good at naming stuff at CyberArk, yeah. What DNA does is it actually reaches out, scans systems, cloud instances, databases for accounts that are there, as well as can dive in to find hard-coded secrets in things like application pools and J2EE applications. Even can jump in and nom down Ansible playbooks. Now, when we found them, we generate this nifty little report that's scary as hell. It's amazing. There's never been a scan that I've done, and I've done something like maybe at this point 200 different DNA scans. There's a guy in the room who's probably double that than me, who works for CyberArk. I've never seen something that didn't make me giggle inside a little bit, like that maniacal giggle you get from watching something terrible happen, like a car crash. Does everybody get those too, or is it just me? I'm kidding. I'm a human, right? I'm not a robot. So DNA allows you to see this information, but the best part about it is, outside of all the nifty stuff that it shows you, you can take action right away. You don't have to pay anybody anything to begin to mitigate risk by discovering the stuff you have going on out there. I have a story. About 3 years ago, I was doing a proof of concept, where we install the CyberArk software, we rotate some passwords, do some kind of stuff for a now client, but then prospect of ours in South Florida, a bank, financial institution. When we did the scan, there was one account that just stuck out like a sore thumb. This account was a member of the domain administrators group. The account syntax was first initial, last name, which tells me that this was the account someone used to log into their workstation and to get their email with. The third part was that it had hashes everywhere, just all over the place. Nearly every system had a hash of this account, and finally, it hadn't been rotated in like a decade. Okay, so I'm like, who is this joker? So I'm working with the CISO. I was working with the CISO, and I was like, who is this person? Let's go find him. And the CISO puts her head down, and she says, "Ask the CEO." What? Oh no! Whoa! So the most visible employee in your company, the one who gets all sorts of crazy spam emails all day long, or their admin does, is a member of the domain admins group, has hashes all over the place, hasn't changed their password in 10 years. Why? Because I don't want to get fired, dude. Okay, that's fair. Cool. I'm not gonna stop you. I'm not gonna slow that train down. Right, because CISOs exist to get fired, right? We all know that, right? Breach happens, CISO gets fired. That's a bad joke, bad security joke. But so what did we do? Like, more importantly, what did we do? We set the password to change on next login and remove the CEO from the domain admins group. Never would have found out. So about 3 hours later, we get a call. It's the CEO. I'm trying to get out. I'm like, CISO answers, "Hello? Why do I have to change my password? New security policy." Oh, okay. I thought I was about to get chased out of there. But look how much risk we mitigated by someone just having to deal with me for 30 minutes. You guys have almost dealt with me for an hour. It's like half that. It's way easier. It gets better, by the way. So I go home feeling real good. I don't go home. I go to my hotel room, which is like a shadow of home. But I go there. Probably got Taco Bell on the way because we're talking about Taco Bell. So go there, come back the next morning. We can't start the POC. Nothing. They're having a Sev1 issue. Something's broken. Sit in the lobby. Okay. So sitting there. An hour passes. They come out and get us. And they bring us in. They don't say a word about it yet. And I mean, you guys, you've seen me for a little bit. You know that I'm probably going to pry. So I'm like, what happened? What happened? Well, something was down. What was it? Well, our vulnerability scanners, something was wrong with them. What was wrong with them? Well, they weren't working. Why weren't they working? Authentication was failing. Why? Well, CEO's account was being used as a service account for our vulnerability scanners. What? Okay, so wait. The most visible employee in the company had a super old password, hashes everywhere. Why did it have hashes everywhere? Because it was being used as a service account for vulnerability scanners. As an attacker, if I gain access to that CEO's account by sending them a really funny cat video, I can now move laterally in the environment and you'll say, oh, it's just the vulnerability scanner. That's fine. Doesn't make a lot of sense. So again, mitigated that risk too. They weren't customers. That was it. That's all we did. So eventually they do, somehow, after dealing with me, they start using CyberArk. 6 months later, we're doing kind of a check-in. So hanging out, talking a little bit. And they're like, you remember that account we found during the DNA scan? And I tried to play it like I didn't. Like I don't tell the story all the freaking time. I was like, no! What account are you talking about? Oh, yeah, you remember the CEO account. Oh, yeah. I hadn't thought about that since then. Yeah, telling it all day long. That's why they don't let me back into Florida, by the way. I'm actually not allowed to go there. Yeah, you remember that account? Yeah. So we found out after we had the rotation that the help desk was using that as their kind of de facto backdoor account. And at this point, all I could ask was, well, why? Why? Because the password was just so easy for them to remember. I didn't ask any further. I don't want to know what it was. But again, that's one scan. It's 30 minutes of time. You can scan 100 systems and be able to find that type of information. This is why we could never charge for something like that. Right? So the way to get DNA is just to come by, talk to one of us, send us an email. I'll give you my email at the end. Hit me up. The way it works is we shoot you a license over. We do track when people are using it because it can be used for evil. And then you can say, license, see you later, Brandon, you suck. Go run your DNA scan, do your stuff. Or you can say, hey, I need a little help. We can actually provide an engineer for you who will help you run the scan, even analyze the results for you. And you don't have to pay us any money or do anything. You can walk away. You can not talk to us. You can throw things at me. It doesn't matter. This needs to happen, right? We need that visibility. But when you find the stuff and you want to start doing rotations, what do you do with it? Well, again, I talked about open source stuff. Around a year and a half ago, CyberArk acquired a company called Conjure. Wizardy stuff. It's really cool. They use like wizarding names and all their tools and things like that. Their tools, our tools. First thing we did was we open sourced it. Conjure is a containerized secrets management platform that is licensed under AGPL3, which means you can use it as much as you want to. There's no cost. It's supported by both the community as well as developers internal to us. If your developers need some place to put secrets and you want to get that from a security company, it's out there, it's available, github.com/cyberark/Conjure. Now there is an enterprise version, of course, but if we're talking about workloads, I would rather you be storing and potentially rotating manually than having them exist inside of code. This is a great way to start. It's also designed for developers, which is always good to have something like that that can be used. Now, couple of parting notes, resources, things like that, and then I'll do a quick recap. First, I mentioned Conjure. I gave you the GitHub link. You can actually hit up conjure.org. The most important part there is up in the top right, there's a little link to our public Slack channel. If you have questions about DevOps secrets management, cloud secrets management, whatever, if you just want to mess with people, join the Slack, chat with us. Myself, as well as our engineering team, so our development team hangs out there too, in addition to a number of our customers, things like that. We also have a bunch of different security tools on our GitHub page as well. Things like a tool called Shimmeet, which does ADFS kind of crushing. We have an attack that we found called Golden SAML because we like Golden Ticket a lot, and Charlie Metallic Factory is cool. You can find all of our tools hanging out right there. Enjoy them, have fun, let us know how things go. And then finally, if you want to spam the hell out of me, BrandonT@cyberark.com. Hit me up. Now, before I get to the most important thing ever and close this out, a couple of parting notes from me. First, human access is important. Cloud management consoles are pretty easy to secure. At the very least, turn multi-factor on for them. You would not let, hopefully, someone log in directly to a domain controller without any sort of secondary authentication. You shouldn't do it for your cloud management consoles either. Same is true of Jenkins. When you deploy Jenkins, by default, it has no authentication. Anybody can log into it, look at jobs, and potentially access all those delicious hard-coded secrets within. Ask your developers to maybe turn on authentication. That's it. It's a step. Even if the password is admin CyberArk sucks, if you want to do it that way, it's better than nothing. So start small, then work things out. For applications, just ask your devs not to hard-code secrets into public source code repositories. That's pretty easy to do. That's not a big thing. Just don't push it to public source. Find a better way. Variabilize it, put it in a file that exists only on-prem. It's a quick way to do it. No cost, no muss, no fuss. Now, the most important thing ever, though, is 5 o'clock today. We're doing a happy hour at Altwater, which if you go outside, turn left in, was it? Atwater, sorry. I put an L in there. At Atwater, go outside, take a left, couple of stumbling steps, you're there. We're doing a happy hour from 5 to 8 today. Come drink beer and other things on us. You had to put up with me for this long. You really do deserve something to thank you for. So please come find us if you don't know. Come find us if you want these cards to get in. We're hanging out in the exhibitor hall, things like that. But any questions? Yes, sir.
So as you get, as some companies get more mature with DevSecOps models, what we're seeing is your DAS tools are inherently not working well with CI/CD, continuous advancement.
Yeah.
Are you seeing any trends? How do you balance, rolling code every hour yet running your DAS? I mean, do you do it at feature level? Do you say, okay, hey, once a week you need to do this, once a month you need to do this?
So honestly, what I'm seeing quite a bit is there's really no rhyme or reason to it. So in terms of performing the scanning operations, any is better than none, and we're seeing a lot of none. So really, I would start with something consumable. Once a month, yes. But you can also look at it as a delta model. If code changes more than Y%, run a scan. Typically, when we're dealing with very agile development processes, you're going to have, less than 5%, less than 10% changes unless you're pushing big feature updates. That's when you can key off some of your scanning processes. So that's what I'd recommend. Do it, but also, if you're having lots of code changes that are minor, base it on the amount of diff that you're encountering between old version and today's version. Cool. Any other questions? How about now? Cool. Thank you all very much.